K-regular graphs are graphs in which each vertex has a degree of k. So in this graph, each vertex has a degree of 2. So this is a 2-regular graph. In this graph, each vertex has a degree of 3. So this is a 3-regular graph. Now, we can show that for every even n big or equal to 4, there exists a 3-regular graph, where n is the amount of vertices. So suppose we have some n amount of vertices, we can put them all in some circle. And since the number of vertices is even, we can split the circle in half, in which this side will be symmetrical to this side. And if that's the case, we can connect each vertex on this side to the opposite vertex of that side. And we do that till we have connected them all. So now each vertex has a degree of 1. But we can also connect each vertex from here to the closest vertex nearby. And for each vertex we can do this. And if we do that, then each vertex will have a degree of 3, and thus will be a 3-regular graph. Now let me show you an example for if n would be 10. This means we have 10 vertices, so let's put them in a circle. Let's put 5 on the top part and symmetrically 5 on the bottom part. So we can connect this vertex with this vertex, we can connect this one with this one, and continue till we have done them all. So now each vertex has a degree of 1, but we want to have it a degree of 3 because we want to construct a 3-regular graph. So we connect the vertices to the closest ones. So now we have constructed a graph on 10 vertices that is 3-regular, because every vertex now has a degree of 3. Now another question might be, how many edges does a k-regular graph has on n vertices? Well, we know that the formula for finding the amount of vertices is a half times the sum of degrees. And we have n amount of vertices, and each vertex has a degree of k because it's k-regular. So the sum of degrees will be n times k. And if we apply this on this example, this is a 3-regular graph on n vertices where n is 10 and k is 3. We plug in a half times 10 times 3 is 30, divided by 2 is 15. So this formula says that this graph should have 15 edges. So let's count if that's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.